Hello, this is Mrs. Huntley. This is Module 5, Lesson 6, Analyzing Functions in Graphs. You should have your packet that says Functions on the front cover, and I'd like you to open, please, to page 30. Add the essential question at the top. How do I analyze a function and graph? And then let's start with the fill-in-the-blank notes. Analyzing functions in graphs. We can analyze parts of a function by describing them. So we want to describe what action is happening in the graph or the function. So a graph can be, or a function can be increasing or decreasing. So increasing or decreasing. Of course, increasing would be positive on the way up, like looking at this graph here. This part, we're starting at 2, it's increasing because it's going up, it's positive. And then after it peaks, it starts decreasing or going down, okay? The other descriptor is going to be linear or nonlinear. Again, linear is a straight line, and nonlinear would be a curving line. So again, looking at this graph here, this is all nonlinear because it's a curve. So if I'm looking between x is 0, here's 0, and x is 4, here's 4. So between this period, let me get a highlighter so you can see where I'm looking if you're not seeing the cursor. So between 0 and 4, that part of the graph, they want to know how we would describe it. So 0 to 4, what's happening there? It's increasing. Is it linear or nonlinear? It would be nonlinear. So increasing and nonlinear. I'm actually going to type it because my typing is neater than my writing. So we're just describing it. We're not saying, we're not trying to calculate anything. We're just describing what's happening. So between x equals 4 and x equals 8. So I'm going to highlight this differently. So x is 4 and x is 8 between those 2 points. So starting from here and then going down there, what's happening to the graph? Hopefully you're recognizing it as decreasing. It's going down in value. And it's still nonlinear. Linear would be super straight, sharp lines. So although this looks relatively straight between these, you can see that there's a little bit of a curve going on there. So let's move on. The distance versus time graph shows us how far two objects are from one another. Considering what the following types of lines on a distance versus time graph would represent. So remember, we were talking about distance and time a lot, and time is our x variable, distance is our y variable. So let's just break this down a little bit before I start talking about what they are. So let me get a pen. And distance, say these are distances, like this is 1 mile, this is 2 miles, this is 3, 4 miles, 5 miles, etc. So, and this is our time, so like 1 minute, 2 minutes, 3 minutes, 4 minutes, etc. So if I'm going on a straight line and it's going up and away, first of all, it's increasing. This is linear, but I'm also getting, I'm traveling at a constant rate of speed and I'm getting farther away as I travel. So how would I describe this? This is an object moving away at a constant rate. This is an object moving away at a constant rate of speed. Looking at B, okay? Again, these are our distances. So if this is like 5 miles here, 4 miles, 3 miles, 2 miles, 1 mile, 0 miles, etc., they're moving, an object moving toward something at a constant rate of speed. So B would be an object moving toward something or coming closer to something. Let's say moving. We'll keep the word moving closer at a constant rate of speed. and see, okay, I'm neither moving toward or away. We could say that if this is maybe 4 miles, that's what it looks like to me. This would be 0 miles. Say this is 4 miles. This is an object at rest. It's not moving closer and it's not moving farther away. So it's an object that is at rest, not changing its distance. Okay, so it's an object at rest, not changing its distance. Looking at D, again, we have our distance, we have our time, but here we're looking at non-linear things. So say this is a person walking, and they start off walking and they're walking at a slow rate, and then all of a sudden they pick up and they start jogging or running, and they get farther and farther away from where they started at a faster rate. So this would be an object moving away at an increasing rate of speed. Okay, and the next one starts off super fast. So say this is a runner, they're sprinting away, they get winded about a mile in, and then they slow down, and then they start walking. So they're getting away, they're still traveling away, but the speed is decreasing as they get farther away. So I would describe this as an object moving away at a decreasing speed. Again, it's still moving away. It just, think of this as like you leave your house and you start off at a sprint, and you sprint, 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 and then you start getting tired and you slow down your pace, until finally you're walking, and then you're maybe, it looks like we're getting really flat here, so maybe we even start resting a little bit. Okay, hopefully this is starting to make sense. It's kind of common sense. We're not using any kind of math or anything to try to say what rate they're walking at or anything. We're just trying to match whatever we're looking at with possible scenarios. So number 1 says match each distance versus time graph with the correct description. So this one, it looks like they're traveling away at a constant rate. We're resting for a time and then traveling away at a constant rate again. Here, traveling away at a constant rate, resting, traveling away, resting, traveling away. Traveling away, resting for a period, coming closer, resting for a period, then traveling away. So let's see what our scenarios are. Kelly got on the bus at her house. The bus made 2 more stops before it arrived at the school. So traveling away, resting, traveling away, that's not 2 stops. Traveling away, this could be a stop. Traveling away, this could be a stop. Traveling away, and then arriving at the destination. It could be the second one. That would be an A. Let's see this one. Traveling away, constant rate, coming closer, constant rate, traveling away. I think it's the middle one. What do you think? I think this is A. Kelly got on the bus. Here's the first bus stop. Going again. Bus stop. Going again. Does that make sense? Okay, part B. Brennan and his dad left for school in his dad's car. They got stopped at the train tracks for several minutes before they were able to continue to school. Which one would that be? Is that going to be the first one or the third one? Why don't you put a B by which one you think it is? And then I'll do the same. Again, left for school, traveling away, stopped at the railroad tracks, continued on. Part C, Cameron left for school with his mom, but remembered he left his English project at home. She took him back home to get his project, and then they headed back to school without any stops. So they travel away, remembered he lost something, they turn around, come back, go in the house and get it, and then on the way to school. Hopefully this is making sense to you. And again, it's kind of just logic. It's logicking through. Number 2 says create a distance versus time graph showing Adam's distance from his house. Label each segment of the graph. Adam left his friend Bailey's house and started walking home. So if this was home here, if this is home at point 0, he's starting a distance away from home. So let's say this is Bailey's house. So he started walking home it looks like at a constant rate. It's not saying that he's increasing or decreasing. I'm going to get a straight line here. So he started walking home. Let's see where we're at now. Adam realized he left his phone at Brody's house, so he turned around to go get it. So now he's going back exactly where he was. I've got to erase this little thing over here because I stuck my finger down. I didn't want to put that there. Sorry about that. Get rid of this little one too. Okay, so he's back at Brody's house, so he's getting his phone. Adam left Brody's a second time and started to walk home. So this is part C. So he left Brody's house and he's starting to walk home. And I'm on the struggle bus. Let me get a line. Oh my goodness. Let's try again. I'm trying to do this without setting my fingers down, which is always a challenge for me. So there we go. We're starting to walk home. And Adam stopped halfway to talk to a friend he passed. So about halfway. And now he's talking to a friend. So we're going to be not going closer or farther. And then he quickly ran home to make it in time for dinner. So now he's got to, oopsie, he's got to be at a faster rate here. Come on now. So now he's quickly running home. So he's picking up his pace. So I'm going to label this up so you can see what I was thinking when I was doing it. So Adam left Brody's house. He realized he left his phone. He had to turn back. Then he started walking home again. He stopped and talked to a friend for a while, and then he realized he was going to be late for dinner, so he had to run the rest of the way. Hopefully this is making sense. Let's take a look at Vanessa, and this one I'm going to invite you to do on your own. I will read it through, and then I want you to fill out what you think that distance time graph is going to look like. Create a distance versus time graph showing Vanessa's distance from her house. Label each segment of the graph. So first she's going to leave her house to run at a steady jogging pace. Increase her speed, but about halfway, got a leg cramp. She sat down to stretch, and she decided to turn around and walk back home at a much slower pace. So she's leaving her house to run at a steady jogging pace, increasing her speed, got halfway, got a leg cramp, sat down, started to stretch, turn around and walk home at a much slower pace. Okay, so what does yours look like? This is how I would probably draw mine. She's starting from home, so we're going to start at the origin. And she's running at a steady pace. Then all of a sudden she starts to pick up her pace, and she's increasing her speed. So we'd go probably a little non-linear there. We're going to increase our speed. We get a leg cramp. We've got to stop and stretch for a little. Oh my goodness, what is that? I have no idea where the pluses came from. And I don't know how to get rid of that one. Let's see what we can do here. Delete. Okay, so we're stretching. Oh my word. We're stretching, so we're not going farther away. We're not coming closer. We're stretching for a while. And then we're going to turn around and we're going to walk home at a much slower rate. That's what mine looks like. If yours looks something like that, that's great. So this is our constant rate, increasing speed, resting, and then coming back at a slower rate. Okay. The graph below shows Justin's distance from his house as he walks to school. Interpret what you think happened at each segment of the graph. So A looks like a constant rate because it's a straight line. B is kind of resting, kind of flat. C, he takes off again and picking up his speed. Maybe he's running late for school. So go ahead and fill A, B, and C out as you would. We're going to say A. You should be filling yours out, not reading from me. Don't copy from me. So Justin leaves home, walking at a constant rate. It looks like he rests for a little bit. Maybe he met up with a friend and he's resting for a bit or talking to his friend. I don't know what he's doing, but he stops walking. He's at rest for a little while. And then C, maybe he notices he's late for school and he takes off, walking away at an increasing speed. I'm going to say continues to school at an increasing speed. Maybe they got on their bikes or something and took off riding their bikes so they were able to ride faster. I don't know. Whatever you came up with, but just so that you have it, that they're increasing their speed. So summarizing today's lesson, we can analyze graphs and functions by describing them as being either increasing or decreasing, linear or nonlinear, and then make up scenarios for that graph. We can either take our written word and draw a graph that would represent it, or we could take a graph and put words with it to represent it. So I hope you enjoyed this lesson. I will see you in school tomorrow. Have a good night.